All right, in this example, we'll investigate the convergence or divergence of each of these infinite series. All right, so here we're going to look for dominant terms and compare tail thickness. We're going to compare tail thickness of this to something that we know converges or diverges. Okay. Okay, so we got 3n plus 5. This is similar to 3n over n cubed. Now, how did I go from here to here? All right, I'll FOIL this out for you. And you'll see that n cubed is that, because now you think about it, as you FOIL this out, this is going to give you some n squared thing. And then n squared times n is going to give you some n cubed thing plus a bunch of stuff that isn't going to really affect, that isn't going to be a dominant term, right? Okay, so anyway, let's see. N, you got n squared minus n minus 2n plus 2. That's n. N squared minus 3n plus 2. Let's see, that's n squared minus n minus 2n plus 2. Yeah, okay, so then that's n cubed minus 3n squared plus 2n. All right, so basically what I found here is that this denominator is n cubed minus 3n squared plus 2n. And so you can see the dominant term is that. So how did I do that before? N minus 1, n minus 2. Okay. Let's see. How did I do that before? I just thought to myself, okay, if you multiply n times n times n, that'll give you the dominant term, n cubed, there, like that. Okay, so that's similar to n over n cubed, 1 over n squared. Now we know this guy converges. This is a p-series. It's a p-series with p equals 2. Remember that the p-series, this is from example 1, from Convergence Example 1, p-series converges when p is greater than 1 and diverges when p is less than or equal to 1. Okay, p equals 2. That tells me converges. So we know this converges. So this converges. All right, so now let's do the same thing here. We've got e to the n plus n, e to the 2n minus n squared. Dominant terms, e to the n grows much faster than n. E to the 2n grows much faster than n squared. So e to the n, e to the 2n, 1 over e to the 2n minus n. 2n minus n is just n, so 1 over e to the n. So now the question is, does that converge or diverge? Okay. Does the associated sum 1 over e to the n, does that thing converge or diverge? So let's look at that. Okay. So now remember with a p-series, it's n to a power. The thing that changes is the is the base, the power stays the same. Now with this thing, the power is changing, right? So when the power is changing, it's oftentimes a geometric series. Okay, so this is actually 1 over e to the n. This is a geometric series. Here r equals 1 over e. So now the question is this between -1 and 1? All right, remember that e is 2.7, I believe, 2.7 and more there. Kind of the decimal expansion goes on forever, like pi. Yeah. Okay. So in any case, e is bigger than 2, which is bigger than 1. So that says 1 over e is less than 1. Yeah. So it's between 1 and -1. It's obviously positive, so it's between 1 and -1. So this thing converges. So this thing converges.